emotional.
You have to admit he doesn't side with it. Why don't you just do your own thing?
Brody's emotional. Him and his girlfriend, Brody. Even though it was a really toxic relationship.
You're doing some
I'm
spirit
sorry.
evil.
Wait, which one?
Not evil.
Which one?
No,
Which
no.
one?
It
has.
Yeah. Brody Fisher.
Sit down.
Just left.
Like a freaking bird.
Brody who?
Green.
All right, here we go. Homework time. I'm gonna go through this quickly because I know you guys already did it.
Oh, thank God.
Yeah.
Brody Fisher and Brittany Purdy.
All right.
Thank God. I hope it actually stays. They'll probably.
Courtney,
She was so terrible. I hate her with every inch of my being.
No, Courtney's in her class now.
Slide in.
Correct.
Yes, you may.
I hate her with every inch of my being. She's a terrible one. Brittany Purdy.
All right, we speak no evil. We are
No,
live.
no, she deserves it.
We
She
are
did some
live.
scummy things.
All right, so here we go. So your homework yesterday was to figure out which one of these theorems and postulates work. We found out yesterday AAA works. The AAA does not.
SSS.
We found out that SSS does. So that means if we have two triangles that share their sides, meaning that the sides are the same. So here's two triangles. And if we know that these sides match up, and these sides match up,
Why am I getting this out?
and these sides match up, then we know that's enough to prove the triangle's congruent. Now you might be saying to yourself, well duh, because everything's congruent, how could the triangles not be congruent? Well here's the thing, bucko, okay, for triangles to be congruent, it's not just their sides that have to be congruent, it's their angles. Now the magic with side, side, side is that when the sides are all congruent, the angles will be as well. And that means the whole triangle is congruent. So if the sides are all the same, so are all the angles, which is convenient, which means the triangles are congruent. Can everyone break those? We're down to like 20 something, and I need at least one for every member of my class, okay? All right. So side, side, side is enough. We also found out yesterday that side, angle, side is also enough to get the job done. So that's when we have two triangles like this, where we have two sides that are matching. So two pairs of sides, and a matching angle that's in between them. Notice that the angle is in between the two sides. So we have side, angle, side. Are you cool with that? That is enough to prove them congruent. We also found out yesterday that this other one does not work. Angle, angle, angle. So just because we know we have two triangles that share all their angles, so for instance, if these angles match up, and these angles match up, and these angles match up, it is not enough to conclude that the triangles are congruent. It doesn't mean they're not congruent, it just means we don't know if they are. So for instance, these two triangles right here. Unbeknownst to you, I secretly measured these out and made sure they were perfectly congruent. But according to what I've given you, which is nothing, you have not enough information to conclude they're congruent, right? They could be, right? But you don't know. Right, exactly. So just because we don't have enough information to prove they are congruent doesn't mean they're not congruent. It just means we don't know, right?
So can they all have the same angles but have at least one different side?
They can have same angles and different sides. So if they have the same sides, they do have the same angles, right?
Yeah.
That works out. But the reverse is not true. So for instance, imagine an equilateral triangle. Somebody tell me what an equilateral triangle is.
All sides are
All
equal.
sides are equal. All sides are equal. Not just the sides, but also what else?
Angles.
The angles, right? So if I were to draw an equilateral triangle, like this, all the angles are equal and all the sides are equal, okay? So if all the angles are equal, we actually know what the angles measure. What are the angles going to measure?
180.
Well, altogether they're going to be 180, but individually they're going to be 60 each, right? Because 60 plus 60 plus 60 is 180, and they have to be evenly divided because they're all three the same. So, got that in your head?
Sure.
If I were to extend this out, that is awful. If I were to extend these out, we would have another equilateral triangle with all of its own sides being the same and all of its angles matching. So just because all the angles match, right, doesn't mean that the triangles will be congruent, right? Here's a situation where I have a big triangle with the same angles as this small triangle, but they are not congruent. Do you see how the angles don't necessarily mean the triangle is going to be congruent?
Yeah.
Okay, so the way I remember angle, angle, angle doesn't matter, right, is I think of two triangles with the same angles. And I think one could be bigger than the other, so they're not necessarily congruent. So angle, angle, angle is not enough, because here's a situation where all the angles match up, but one triangle is definitely bigger than the other triangle. Cool?
Cool.
So angle, angle, angle does not work. So that's a no. These are yeses. What I wanted you guys to do is try out some other ones to see if they work, right? We had this one, angle, angle, side. Our favorite that we're praying works, so we can write it on the test and I don't mark it wrong, right? And then we have another one that I wanted you to check. What's the last one that I wanted you to check? That's a great question.
Well, actually,
Angle, side, angle. So those are the ones I wanted you to check. Let's try angle, side, angle first to see if it does. This is what you did for your homework, which means you'll be turning it in on Friday. I'm going to go through this quickly because I know you've already done it, right?
Oh, yeah.
So let's try ASA and see if it works.
I actually did do it, and I feel proud.
Again, it's due Friday.
Wait, wouldn't that be the same as angle side? No. Maybe. No.
Order matters. The side is between the two angles.
Wait, you don't have to say size matter.
I got tons back there.
According to anyway.
Yeah,
Sorry for getting out of
Alright, so let's check out angle, side, angle. That means we need to make two triangles that share two angles and the side in between them. So I'm going to draw the side first just because I think it's easier to draw sides than it is to draw angles without any sides, right? That seems kind of mysterious out there. So I'm going to draw a side. I have a ruler right here that goes from 1 to 6 inches. I would prefer a number between 1 and 3 for the side. So Schloffer, give me a number between 1 and 3. 2, excellent. So I'm going to draw at a side length of 2 right here. Let's do this in color, actually. And I'm going to draw a side length of 2. I don't have to draw it flat like this. I could draw it like that. It doesn't matter. I'm just going to draw it like this for ease of operation. So these two are congruent. I measured them out to make sure. So we have matching sides between our triangles. Now we need two matching angles. So to do that, again, this is kind of capped off here and here. Capped. Right? So I need an angle, preferably one that's a multiple of 10. That's between 80 and 90, or 80 and 10.
70.
70, all right. So here's 70 degrees from here, right? From here to here is 70. It's kind of hard to see with that glare. Let me move it a little bit. So there's a 70-degree angle right there. So I'm going to draw that. And again, it doesn't matter how long this line is, as long as it's this angle. So here's the angle that we were talking about. And we're going to want to make sure that both our triangles have that same angle. So you said 70. So I'm going to do a dot for 70. Boring. I'm yawning in math class.
Can't help it.
What is that? Supposed to be the line.
Yep. The reason I did it dashed is so you don't get bogged down on this idea the line has to be a certain length, right? All we care about is this line being the right length and this being the right angle, right? Angle and a side. Doesn't matter how long that side is. It could be this long, it could be that long, doesn't matter, okay? Now we need another angle. So again, I'm not going to worry about the side length. I would prefer something that is small.
69.
69. Can you give me a multiple of 10?
There's a joke to be made there.
30.
You said small. I said 69. There's a joke.
30 works. All right. So here's a 30-degree angle for both of these. Again, it doesn't matter the length of the line.
Some people suck.
Wait.
What?
My fault.
My fault.
All right, ladies in the back, can you please stop talking about whatever it is you're talking about, or at least do so quieter?
Fine.
I mean, either do or do not. All right, so those two angles have to be the same, and the side in between them has to be the same. Check. So you'll notice that right away, we made the same triangle. We're kind of locked into how long these have to be, because they end up intersecting. So it turns out these triangles will always be congruent if we have one segment and two angles on either side of it the same. It'll always make the same triangle. So ASA works. That is enough information to conclude the triangles are exactly the same. So here's ASA, that's correct. That's when we have two triangles that have two angles that are congruent, one on either side of the congruent side. Again, order matters here. So if those are my two congruent angles, the side must be the one between them. This side. I cannot stress enough how much order matters. One of the dumbest things to get wrong, but one of the most common things to get wrong on this quiz this Friday is to not realize that order matters and say that this is angle, angle, side. Because two angles on the side, right?
No.
It ain't. It's separate. Order matters. This is angle, side, angle because the side is between the angles, not off on the side. Speaking of angle, angle, side, let's try that one next. So two angles and a side in that order.
Yeah, but we have a test this Friday.
Angle, angle, side. So again, I'm going to draw the side first, just because that's easier for me to do.
Roger.
So Rosie, give me a side length that's between 1 and 4.
4.
2.
Good job, Rosie. Damn it. 2 it is. So that's going to be the same as this. Guaranteed.
Yes.
All right, cool. Dykema, give me an angle between 10 and 80 that's a multiple of 10.
6.
Well, that is neither between 10 nor 80.
Well, like I meant
Or
like
multiple
10
of
times 6.
So 60. Got it. All right, so 60
Oh
it
my
is.
god. Good job.
Right.
Congrats.
So here's 60. Actually, that's not 60. This
That's
is
120.
60. No, this is 60 because I'm going from this angle,
Oh,
right from here to here. That's 60. It's 120 from here to here.
Discuss this.
I think Kayla was confused earlier because I actually didn't do the angle she asked me to do. I did the opposite of that, but when you care. All right. So, again, doesn't matter how long this line is. All we care about is the angle. So I'm going to do a dashed line to help me remember that. I think it's really easy. Oops.
What,
focus on the
what
line.
angle measure?
Gross. That's 60. Not that it matters, right? As long as you're consistent. So I'm going to do 60 again over here. I could even do 60 here and have these two match up. That's fine, as long as they match, right? But for visual cleanness, I will do it on the same side.
I couldn't stop.
All right, so these two angles are equal.
I couldn't stop falling.
Now, here's the thing. We're not doing angle, side angle, because that would be where these two match and this match. So we need an angle over here now. So, I need another angle. Katie, give me an angle that is acute, but bigger than 10. Because 10 is too small. 20, okay. So I'm going to go over here. It doesn't matter where I put this because, again, it doesn't matter how long this line is. I just need to make sure that when I do a 20 degree, it does hit down here. So here's 20. I want to make sure that intersects with this line. So I'm going to have to go way off
Whoa.
over to like here.
How you doing, man? Oh, that's not well.
And that'll end up intersecting. All right, so I'm going to put a dot here
That is neat.
and a dot there.
That was the weirdest.
Okay, so check it out.
Whoa.
That's where my protractor was centered. So I need to extend this line out to there. Again, doesn't matter how long it is. And then when I draw this line, it should intersect and make a triangle. And that angle will be 20 degrees. Not this angle, but this angle right here. Again, if it was this angle, we'd have angle, side angle. That's not what we're looking for, right?
It's
So,
side.
I'm going to draw a dashed line here. And the angle we're interested in having being congruent is this one. Okay? Now, if I were to do that over here as well, I think you can kind of tell I'm going to get the same thing, right? So
Yeah.
here's where I want this. I want 20 degrees. It's going to be way off over here. Looks like that will get me 20. Here's where my protractor ended up, right there.
Yeah, it didn't even touch anything else.
So I'm going to do this. That's close enough. And then this guy gets extended. It doesn't matter how long they are. And so I think you can tell that angle, angle, side is enough to prove the triangles are congruent. It ends up locking you into a certain triangle, right? There's only one triangle you can make that has this side length and these two angles. Yes?
Okay, I don't mean this in like a bad way.
No, it's okay.
Like, what's the purpose behind
Exactly.
it?
So, one way of teaching this is have you memorize all these guys and which ones work and which ones don't. I would rather, at least initially, show you where this logic is coming from. That way, if you forget which ones work and which ones don't, that you can work your way through it, right? That's the point, to visualize this stuff. Where does it come from? Also, these right here, it turns out, one of these guys on here has to be a postulate. The rest can be theorems. So what do I mean by that? A theorem is something that is proven based on other theorems or postulates, okay? A postulate is something we accept to be true because how could it be anything else? There's no good way to prove it, but it has to be true. So for all of these to be true and provable, one of these we have to accept as true no matter what. We just take it with faith. And we're going to have this one be that for this class. And then next week we're going to prove all these using this. Okay? So I want you to get an idea of the difference between them. But it's a very valid question that you're asking. In fact, if you're not asking that question, why does this matter all the time, then you're not actually learning. Right? You should know why we're doing what we're doing and why it matters and why it makes sense. So thank you for asking. So it turns out AAS is enough, it locks in, right? So these two triangles will end up being congruent if they're two angles and one side are the same. So AAS does work. They will be congruent. Again, AAA, we don't know that they aren't congruent. It's just, we're not sure, right? This one we're sure for sure. For sure.
I don't know that you don't know because it says
So two angles
I'm sure.
and a side. I like that. I like that.
Right. That's
Isn't that so much easier?
This is actually
it's
something I
Tina
did
Belcher.
last year. Isn't that fine?
Is it from Family Guy? Somebody
Nothing is
Just
from
do that until
Family
they go
Guy.
away.
I don't know if this means.
Yeah.
I will. Let's do ass. All right. Everybody, look at this ass.
I don't like it.
Fat
Okay,
ass.
well, are we not on live here, or is that like?
We're live. Jenna is requesting ASS. All right. Ass.
Thick ass boy.
Let's see if ass works.
Damn, boy.
All right. We are praying. We are hoping.
We're praying.
We are praying to our
No,
God
no, she's not.
that this one works. So you can write this on your test and it will
And
be
so we
marked
can
wrong.
figure
Your
it out.
God is ass.
We are praying.
What are you pointing to?
All right. So
You pointed to Schwab.
if we know two sides of the triangles are the same and one angle is the same, is that enough to say the triangles will always be the same?
Sure.
We're hoping, we're praying. We want to be able to write this down, okay? So here we go. I'm going to make two sides first because that's easier for me to make, and then we'll worry about the angle later. So, Dykema, give me a side length between 1 and 4.
3.
Okay.
I don't get it, Jay.
Explain. So there's length 3.
Why is there a mark right there? 3 inches.
Cucumber walks it to a mollusk walks it to a sea cucumber.
Mr. McNally, is there a 3-inch mark it with your ruler?
Fine.
Oh,
I'm playing
big
dumb.
boy!
All right.
Great.
Measuring tape is required. All right, so here we are. So we have options, right? All right, so both sides are the same. We need another side like that's the same. Now, I don't want to just count squares or something because, again, it's not about the angle between the sides, right? It's just two random sides connected up, okay? So I need another side length. Give me another one. 7. Could I have smaller, please? 5. Well, that's still pretty big. Okay. All right. So
That's what she said.
here we go. I don't think she did. All right. Wow.
Those are jokes you made there.
Honestly,
Jenna, please no. Please no.
Don't say
Please no,
anything, Jenna.
no. Please no,
You're
Jenna.
gonna shoot yourself in the foot. Don't say
Hush.
it.
Jenna.
I
Your brain is
wasn't
not
gonna-
well endowed.
Please.
You're
I
going to
wasn't
lose.
gonna
Please.
say anything bad.
Please.
But it's gonna sound
Jevin
wrong
is
when
not
I say
saying
it.
it.
All right.
Jevin is now.
Back to
Now
math.
she's crying.
It's 6th hour,
Now we
everybody.
get it.
All right, so these two sides are the same. Check and check, right? Here's our side. Here's our other side. Now we just need one angle to be the same. And you might notice already that there's no way these are going to be congruent, right? There's no possible way. The only way is if these were the same angle. Now, if these were the same angle, we'd have side, angle, side, right?
No.
And we already know that works. So, angle, side, side alone does not work. Yes.
How did you do that? How did you do the angle? I don't know how to do that.
I just did a random angle.
Oh. What?
The joke.
I knew I needed a length of 5 because that's what we chose, right? And I just set it up as separate angles because it doesn't say the angle between the sides has to be anything. There's no angle between those two S's, right? If there were and it had to be the same, then we'd have side, angle, side. We already know that works. We're testing two sides with a random angle. Can you guys shut up, please? Two sides with a random angle. No, she just can't hear me, okay? Two sides with a random angle in between them, right? Because there's no specified angle, right? And then a random angle over here that matches up. Now, you'll notice I can't even make these angles match up. not going to work. So I'm not able to do ASS and prove the triangle's congruent.
We can say it's wrong though.
Which is a shame. So neither ass nor ass backwards works. Okay? Which makes sense when you think about it. It should, because it's ass backwards. Right? Most often you guys will write ASS and realize, oh, that's not one that doesn't work, right? Because you'll see, oh, that word, right? But a lot of you guys on Friday will write SSA and not realize that doesn't work either, right? So remember, both ass and ass backwards do not work.
Those are the only ones.
Okay?
Well, that
So it turns out every combination of A and S, I know, laugh about it for a couple seconds.
You get.
Ah, ass.
Lainey, you need to control your friend. Keep that down.
Is everyone so to say?
No, that's how you gotta remember it. You gotta be like, ah, ass.
Well, you need
But I'm not saying everyone
What?
else. Sorry.
Not you.
Sorry.
Sorry, stop.
Why is there, Mark?
All right, bring it back in. I think we had enough to laugh about it. So it turns out that every combination of A and S, right, the only two that don't work are AAA and ass backwards. Okay, everything else works. So the way I remember these is not to memorize each individual one. That's a pain in the right. What I do is I remember the ones that don't work. Okay,
not a pain in the
now order matters, right? Again, angle side is different than angle, even though they both have two angles and one side. Angle side has two angles, then a side. Angle has two angles with a side in between. You smell what I'm stepping in?
See.
Awesome. So there is an exception for this guy. I know you're excited about that. It turns out ass does work in one case and one case only. And because it's such a specific case, we call it by a different name to help you remember what case it has to be in. So
Ass.
here it is. Angle side works in one particular scenario, and it's when we have right angles. So for a right triangle, like this, that's a right triangle.
Yeah.
Okay? If I know that I have this and this the same as this triangle, I know the triangles will be congruent.
Yeah.
Guaranteed. This is ASS, right? It's not SAS, right? There's no angle here that we know. It's when we know the hypotenuse and one of the legs that we're able to say they're congruent. So we call this HL theorem.
Isn't there two legs?
Hypotenuse legs. There is two legs. So if we knew these two matched in the hypotenuse, or if we knew these two matched in the hypotenuse, we would win. Okay? So HL is the only time that angle side works. So if you find yourself writing ASS, either one, you're wrong and you just did the problem wrong, or two, maybe you're actually looking at a 90-degree triangle and what you really want to write is HL.
Hotline bling.
Okay? Hypotenuse leg. We call it hypotenuse leg because only 90-degree triangles have a hypotenuse, because a hypotenuse is the side that's opposite a 90-degree angle. The hypotenuse is always the biggest side, and we know this to be true because a squared plus b squared equals c squared. And if this is a, that's b, and that's c, we're adding two smaller sides up to get a bigger one. There's no way we could take two bigger sides and get a small one, right? Can you take two big things and add them up to get a small thing? No way, right? So these must be smaller than this, right, if they add up to this. Even if A was like equal to C, well then B would have to be 0, we wouldn't have a triangle, right? So A at the very least has to be slightly smaller than C. So C will always be the biggest side, C is always the hypotenuse. So the hypotenuse is always across from the 90-degree, and it's always the biggest side on a right angle, okay? Now, why is the biggest side always across from the 90-degree angle? Why?
Because it needs to.
Why? How come it has to be the biggest side across from the 90?
farthest.
Yeah, there's
That's
this,
how, 'cause
right?
that's how it works.
But even without PFAD, how do we know that the biggest side will be across from the 90 every time?
Because
It
the,
just
90,
works.
the 90 doesn't go like that. And the,
The two farthest points have to be the same.
oh, because all the angles add up to a thing, right?
Okay, so Laura Lee's onto something. You're not wrong, okay?
Yeah,
And I think
not
it'll all
wrong.
come together. It's good that you guys thought about this, okay? So let me pull it all together. Laura Lee mentioned that the angles of a triangle, the internal angles, all add up to something. What do they all add up to?
180.
180. So
Okay,
if that's
okay.
90, how much is left over for these two?
Not very
90. There's 90 left over for these two. So imagine that you wanted to make this angle as big as possible so it could compete with this one, right? What's the biggest this angle could be? If that's 90, what's the biggest that could be?
40.
Oh, it could be 50 and 30, or 50 and 40.
But it couldn't. 89.
45.
It could be 89.999999999. We have to have a little bit left over for this guy, otherwise we don't have a triangle, right? We'd have two angles, that'd be a 0.
45.
So as big as this one can be is 89.9 repeating, which is still smaller than this. So this is always going to be the biggest angle in a triangle. If you have a right triangle, the 90 degree will always be the biggest angle.
Yes.
Now there are triangles with bigger angles, right? But when you're talking about a right angle triangle, the 90 will always end up being the biggest because the biggest the other one could be 89.9 repeating because there has to be a little left over. So of course the biggest side will be across from the biggest angle. That makes sense. Look at my hands. If my hands are apart like this, imagine I'm trying to make a triangle here. I don't have a third hand, so I can't connect the top, but you probably could with your mind, right? Use your imagination.
Mind your fingers.
Now, if I make the angle at the bottom bigger, what happens to the invisible side? It sucks. It gets bigger. The bigger the angle, the more it opens up, which means the bigger that opposite side will be. So the bigger angle has the bigger opposite side.
I feel smart.
Bigger the angle, the bigger the opposite side. The smaller the angle, the smaller the opposite side.
Literally.
So for HL, only works for right angle triangles because only right angle triangles have a hypotenuse and a leg. If you know both legs are congruent, does that mean these triangles are the same?
Yes.
Well,
Why?
You can drag them out more than they will be the same or they're not.
Let's talk about this. I said hypotenuse leg is enough to prove two right triangles congruent. So if you have a hypotenuse and a leg, you're good. What about if you have both legs? Is that enough to prove it? Who says no? You say no because it's not the hypotenuse and leg, right? You need a hypotenuse and a leg. That makes a lot of sense. But it was a trick question. That is actually enough to prove it, right? Why?
Because they look.
I want you to think about it. Shut up and think for a couple seconds, even if you know the answer. Okay? Take 5 seconds to think about it, and then I'll ask. How do we know these are congruent, given this information? Even though it's not hypotenuse leg, right?
Because
Pause.
We already did 5 seconds.
Give it to me.
Right angle.
Okay.
90-degree angle.
Nope, has nothing to do with that
That's what I
necessarily.
said. Right,
maybe
right.
it's-
Has nothing to do with it being specifically 90, actually. Yeah.
It's a right angle.
Because it gives you two of those sides that are both congruent, so.
It's congruent by side angle side.
Oh, yeah.
Side angle side.
Same thing.
I guarantee this will be on the quiz Friday. And you'll go, HL. Actually, no, because you don't know the hypotenuse. So you can't use HL. But you can use side angle side.
Mr. Mac, are we gonna get like notes on this?
Yeah. Kind of, not
but
really.
and a
Eddie
review
Wally. A review packet on Thursday. So, turns out we have one more to add to this list, and it's HL. Trip. And HL is the special case when we have a right triangle
Hey, I can't see.
with its hypotenuse and leg matching.
It didn't even move. You moved
Mr.
paper.
Mac, it's frozen.
What?
It's frozen.
Oh no, rip.
Frozen 2 sucks.
It does suck, actually. It is objectively a bad film, and it's okay. It didn't have to be a good film. It
I
still
thought
made
it was
lots of money
alright.
and had an okay song in it. But it was objectively a bad film, and that's okay.
Storyline, but Olaf is winning.
Just like
Yeah.
Cars.
Yeah, they should have made an Olaf short and called it a day, but it wouldn't have made nearly enough money.
But Cars.
They should have killed
Cars
off
2
Olaf.
sucked and they made a Cars 3.
They already have an Olaf.
Major character death.
That's right. So HL is ASS, but just for right triangles. All right, let's get your homework.
No way, Jose.
I
No
know
way.
Samantha.
What,
She's my best friend.
Yeah.
In Texas. Really.
Wish I was back. There?
She had two. Because I said Texas.
Okay, but
You like my cat? You like
yeah, you suck.
28 years.
Where'd my pencil go?
You can keep
Hey,
on by.
I need that lead. You better not break that. Sydney, no. Don't break my leg.
Mac, I have a question.
Yeah?
Like, getting a sugar daddy a viable option to pay rent?
I mean, will it work? If your sugar daddy follows through, yes.
Okay, cool.
But they're sketchy, so I wouldn't bank on it.
Okay.
I don't have that, so yeah.
You have Jason?
Why are you talking?
Okay, no. Give
Why, Lorelei, do you know a good one? I can use one.
Actually, dude, my cousin.
$8 until Friday, guys. $8.
Dude, my
You know how many
cousin.
Jack's pizzas I can buy with $8? I thought you were I thought you were about to say
only
Jack
get
Daniels.
$8?
What?
You only get $8.
I got
Actually, Mac,
$8 in my bank account.
I do
Alright.
know. I
That's
do.
the most I've had in a long time, guys. Like
Yeah, he
consistently,
was
like after
negative
bills.
3
This is
something.
great. Life
was?
is good right now.
No, my cousin
was
has like
negative
6 sugar daddies, and she's living in a pen.
And now I'm doing lunch duty, and so I'm making extra money. It's swimming in dollars.
I want to be
Okay?
a sugar.
I can buy 2.5 Jack's pizzas right now, no questions asked.
Seriously, my cousin Caitlin has like. That's a weird question to ask.
Enough. All right.
He
So
has like one to pay rent, one for food, one for shoes, one for makeup. She's
What
I
about
won't
gas?
die.
What about gas
I
money?
am
What
immortal.
What about gas money?
about your gas?
I don't need gas. I have a gas card that I got from a student for a Christmas present. I'm good. These things are infinite.
I want to sugar mom.
There's no reason why
Keep on.
Are you an
All right, here we go. One more time. So, brief pair of triangles state the postulate or theorem that can be used to conclude the triangles congruent. So, I told you earlier that one of these has to be called a postulate for us to be able to prove the rest. Right now, you don't care about that. We're going to prove that next week. All of these are your theorems or postulates that you can use, okay? Now, we know that we can't use AAA and we can't use ASS, unfortunately, right? If you have the urge to use ASS, you really want to use HL, okay? So, here we go. Number one. All right, so here we are. More important than knowing these, so Jenna, more important than knowing these is probably being able to see the problem. So I'm not going to be worrying about these. All of these are pretty easy once you get the hang of it. You'll have it memorized because you'll understand what it means. So let's focus on that first. Trust me, okay? So here are our two triangles. Technically we have three. You see the big one, right? But that's not the one we're talking about because there's no way that's congruent to the other two, right? It's bigger. It's not going to work. So we're looking at a left triangle and a right side triangle, okay? We are given that this side and this side are congruent, and we're also given that these two angles are congruent. Now, that's not enough to get the job done, right? We need at least three things. Unless it's a right triangle, we can use HL, right? But these aren't necessarily right triangles. We don't know that for sure. Later, we'll prove that they actually are. But we don't know that yet, okay? So, there needs to be more information here that we're not seeing. Does anybody see it? No talking. If you're smiling before raising your hand, I will not call on you because I know you know the answer.
You have a 90-degree angle.
Nope, we don't. We don't know for sure yet. It looks like it, but it's not quite.
Angle.
Okay.
I'm not measuring.
We don't know for sure that that's 90 degrees. It looks like it is. Or that these sides are equal. We don't
You're a
know
liar.
that. Even if we did, ASS isn't going to get it done, right?
You're a liar. It is 90.
You see it? It will be, but we don't know that yet. We're going to prove that later. The middle line, very good. They share GI.
Oh, we're
So see how they share it? Well, if they share it, it's the same for both, right?
Yeah.
So we have side, angle, side. Now, again, when you're going to write why they're congruent, I always cover up one of the triangles to make sure I don't say like side, angle, angle on accident, right? Cover up, so you're just looking at one triangle. What do we have here? A side and a side with an angle in between. So side, angle, side. I'm going to write that. And that's enough information to prove their congruence. Seeing the shared side is a huge key to getting this stuff right. So seeing it's way more important. So if you're lost and you think, man, there's not enough information there, look for shared sides. That's a huge key. Look at number 2. What do you notice right off the bat? Shared side, they share NP.
And it's
So now we have a pair of sides matching, a pair of sides matching, and another pair of sides matching, which means that they are congruent by what? Purple Cobras, right? Anyone watch Dodgeball?
Great movie.
You can dodge a ball.
Great movie.
With Vince Vaughn.
Triple S. I cannot watch the ending of that without like puking. All right,
Oh, hey,
number 3.
I got it right. I said I bet it'll be SS.
Screw you.
Again,
Norris.
finding the shared side is key, right? Don't let that trip you up on Friday. Number 3, hint, it's not a shared side. We have an angle here and an angle there, and a side there and a side there. Now, pretend we had a shared side. Unless these are 90, that's not enough, because that'd be angle side side, right?
HL.
So we're missing something else. It's not HL. We don't know that they're 90.
Well, they look 90.
ASA, you said angle side angle. Where do you see that extra angle? Does anybody see it? Think back to first semester. May. Vertical angles. She said vertical angles. Where are the vertical angles? Somebody tell me the angles.
C.
All of them.
Oh, but
Actually, that's what.
Oh, angle C and angle C.
BCA. Again, there's lots of angle C's, right? BCA and DCE are the same angle because of vertical angles. Remember scissors theorem?
They scissor each other. Your words are mine.
Okay. You looked over well.
D or no.
All right, boys. I need you to stop. You're distracting others around you, and it's getting annoying. okay? Because they're distracted, they can't learn, and that really pisses me off. Normally I wouldn't care, because it's your grade, right? But it's kind of messing up other people now, and they're too nice to say anything, so I'm going to say it for them. So, when two lines intersect, the top and the bottom angles will always be the same, no matter how they intersect, right? See how the angles are always the same top and bottom, no matter how I make these lines intersect? Same thing with the left and right side. They're always going to be the same angle. That's scissors theorem, otherwise known as vertical angles, VAT. So these two angles make a scissor, so they're going to be congruent. So how do I know the triangles are congruent? Look at one at a time. What do I have here? Angle, side, angle. Not angle, angle, side. The side is between the two angles, so it's angle, side, angle. I guarantee someone is going to write angle, angle, side for this one and get it wrong because they didn't realize the side is in between the angles. Yes?
I don't get how you like how you figure out what it is, like side angle or side.
I'm going to go over that. So Jenna, out of these three, which one would you say was the toughest for you? Maybe they all were really tough, but which was the toughest, do you think? What's the hardest one they answered? 1, 2, or 3?
I don't know.
Not sure? Does anybody have an opinion on which one they think is hardest?
3
Three.
probably would.
3? Is that what you'd say? 3? Okay, fair enough, fair enough. Alright, so here's what I want to do. Look back at number 1. Finding that shared side is key. Jenna, do you see that they share that side? Okay, so now that we have that, if we look at one triangle, just the left side, okay? Notice that we have a side, and an angle all together, right? Now, order matters. So if I start here, it's side, then I bump into an angle, then a side. So it's side, angle, side. Are you seeing that? If I went from here, it'd still be side, angle, side. I can't start here because I have to go left and then right. So we pick a side, and we start from there. So it's side, angle, side, that makes it congruent. That's what they share, a side, an angle, and a side. Over here, it's the same thing, it's just the 3 sides. Side, side, side is shared. Side, side, side. Again, look at one triangle at a time, and I think it becomes more obvious. 3 sides, 3 S's. Over here, we're sharing a pair of angles, and a pair of sides. Order matters. So I'm not going to write AAS. I'm going to write ASA. Does that make sense, how I pick somewhere to start, and it's ASA?
Yeah.
Okay, I can't say AAS because the angles aren't next to each other. If I had these two angles, Jenna, let me cover this up. If I had these two angles, this angle here and that angle there, and that side, then it would be AAS.
Yeah.
But I don't, I have angle, side, angle. Better? Okay, I'll take better.
What?
What?
Why did you start there at B and then did A?
I could have also started here and done angle, side, angle. I just can't start in the middle because then I'd have to like go out of order, right? Side, angle, and then jump over here.
But like if you start at C and then went left, that would be
I would cross, that's a great question. So I can't just go angle, angle, side because look, I pass an angle on the way. I can't do angle, skip an angle, say an angle, right? That doesn't work. Okay? So we have angle, side, angle in other words. Better? Okay, so I think you're seeing some common mistakes you might make. Start looking out for those. Let's look at number 4. We're given that these two angles are the same, and we're given that these two angles are the same. Not enough information, but what else jumps out at you? Go ahead. Shared side. Look at one triangle at a time. You might be saying angle, side, angle because of that, and you'd be wrong. It's angle, side, angle because of these guys.
That's what I was looking at.
Okay?
Came up with that.
Cover up one of the triangles and it won't screw you up. So it's angle with a side in the middle, angle.
I want an angle. I'm starting to get confident with this.
Starting to get it? Don't get too confident. Make sure you're questioning yourself. Okay? Let's look at number 7. Jenna, what do you notice right away about number 7?
The angles.
Exactly. We have vertical angles right here.
They
Jenna.
scissor each
Excellent job. Your words, not mine.
Side angle. Angle.
So now, before we do anything, let's cover up one of the triangles so we can get the true story. What theorem are we going to use to prove those triangles congruent then? What do they have in common? AAS. You could also do SAA. Doesn't matter whether it's forward or backwards. But notice the side isn't between the angles, right? So it's not going to be ASA. It's going to be AAS. Okay?
Would that be the same thing for 5?
For 5?
Yes.
Yes. Now, Jenna, you could have written it SAA backwards. That's fine too, right? Okay.
Okay, I understand that.
Look at number 11. This one's for self-development. This one is tough. Look at number 11. What do you notice right away?
They share a line.
They share a line, so make sure you mark that. We have sides here, and then we have angles here. Now here's the problem. If we look at one triangle, it looks like we have ASS, which does not work. That's not one of our theorems. HL maybe, but we don't know it's 90, right? We need more information to get this done. This one's tough. We've had 2 classes solve it so far. 3 people in 2 classes have figured it out. It's for self-development. I want you to think back to last semester. It takes a lot. This one's the toughest one. Okay? I'll give you a hint. Extend your lines. Think about the definition of parallel. All right.
No.
Same thing with 13, 14, 15, and all those. Those are all pretty much the same as what we've been doing. I think 14 you should see vertical angles, 13 you should see shared line, 15 shared line, 16 shared line, 17 shared line, 18 shared line. So the 2 things you want to look for are shared lines and vertical angles, right? Those are the 2 big ones. For number 1 down here, it says triangle FIG is congruent to what other triangle? So this says go back and look at number 1. FIG is congruent to what triangle? IGH. Now here's the deal. When we write this, if they said FIG, when we write which triangle it's congruent to, we want to say HIG. We want to match up the letters as much as possible, okay? That'll help us because then both angle I's are easy to see that they're going to be the same. Same thing with both angle G's. And then F and H will be congruent. So when you write FIG, you want to write that it's congruent to HIG in that order. Order matters. That's going to help you out a lot later. So make sure you write it in the correct order. Is everybody cool with the instructions? We're going to go over this tomorrow. Again, if you get lost on it or confused, great. Circle it, come in with questions. That's what homework review at the beginning of class is for. We have an early dismissal tomorrow, which means no warm-up. WAC kids will be gone for most of the day for my early classes, right? So what we're going to do is we're going to do homework review. We're going to make sure we're good on this stuff, and we'll have a little bit extra on top of it. And then Thursday we'll do a review for our first quiz. This first quiz is the easiest quiz all semester, which means if you get it, you're going to knock it out of the park for you guys. If you don't get it, it's going to be a thing that weighs you down and you don't have to fix later. So I would encourage you to make sure you really know your crap on this one and start out on the right foot. Remember, easy quizzes are worth just as much as hard quizzes, which means if you bomb a hard quiz later, this easy quiz can help balance that out, okay? And it's not easy until you know it. So if you're like, I don't know if this is easy or not, great. That means you know you're not sure. Come see me. If you don't feel great about this by the end of tomorrow, and especially by the end of Thursday, you need to come see me before you take the quiz, okay?
Okay.
It is doable. You're probably missing something this small that's holding you back, okay? Start out on the right foot. Remember the portfolios you wrote? Remember how last semester went?
Why you got vegetables?
You can start off better this semester. Talking to you, okay?
Your vegetable
I did
oil,
write that
like,
yeah, why you have vegetable oil?
because he's separating it from something
I'm
else.
teaching algebra next class. That's why.
Yes.
We're doing mixture problems. And they're very counterintuitive if you just look at the algebra, but once you see how mixtures work, it's like, oh, duh. For instance, if I have 50% oil and water, and I have 25% oil and water over here, if I mix them together,
How would not have 100% mixture?
it's not going to be 100%.
No?
A lot of people might say 100, or they might say 25. Turns out if you mix a 50 and a 25 together, you're going to get somewhere in between.
No, I need
Really?
Not 75.
Why put GW30 in like GW?
Because what will happen, Lane, is you'll have the whole tank. Here's 50, right? And here's a 75%. Let's say that, okay? Not when we're at
Oh, I want to see
87,
one of those
we're at
squares
water.
again.
Now we're going to have
Those
double
things are so
that.
cool.
You want me to make
There's
this quick?
50
I don't know.
and 75 together. So it's going to be somewhere between.
It's
50
magic when
and
Mac
75
does it.
Because those two are going to go together to make this, and then all that water is going to go up. Yeah, it's counterintuitive. It's easy to show us stuff. Go away.
That is just the coolest thing in the world.
Here's at 100%.
Uh-huh,
Here's 20%.
uh-huh.
Here's 50%, and here's where they overlap.
I
Yeah.
love that.
Which is why 25% times 50% is going to get you the probability of both those things happening.
I love that.
Oh yes.
Is the bell ring?
I don't know.
No.
I was done, so
Okay, cool.
works for me. How early did I let them out? Because I have a bad habit of doing that. Oh, it's 1 minute late technically. How are you?
Wait, the bell did
Oh,
ring?
hold on 1 second. It should have rang, according to the